Good afternoon, students. Am I audible?
Yes, sir.
Okay, fine. Okay. So a very good afternoon, students. Now I am going to start with a vector representation of an alternating quantities today. Fine. So first of all, I'm going to share the screen. I hope the screen is visible now. Now, electrical quantities may be a voltage or current that we can represent into a vector form also. So here we know that as the quantity may be a voltage or maybe a current. So this is the diagram, or we can say waveform with respect to time, t. And this is the total time period. We can say it is a capital T. So as respect to the axis, if the vector starts rotating at any instant of time, for an example at A dash, the induced EMF at that instant or the current induced at that electrical alternating quantities that we can represent with the vector here. Now, for an example, if another quantity that is acting here, suppose this is coil 1. Now, if you consider the coil 2 also, so with respect to this, there is an angle theta 1 and here it is angle theta 2. Therefore, these two different quantities that we can represent in the same waveform diagram, and this coils which is made an angle with axis. Similarly, we can also convert this into a vector form. So this is your first vector. Now, if you want to measure the vector, we can draw a vector also. Suppose if there is an equation of I, we know that the equation is Im sine omega t plus or minus theta or plus or minus phi. Now, if I take an example of the amplitude is 5 ampere maximum sine omega t plus 0. So in this condition, I can draw a vector so this is current with respect to time t. This is the current. Now amplitude here, Im maximum is 5. So I can plot maximum 5 ampere. Fine. Now it makes an angle 0. So it will start from here. And the graph will be like this. Now same thing I can represent in a vector form also. So the vector form is here. Suppose if I want to measure with respect to time t, I can also do this. Im is 5, means the magnitude is 5. So 5 divisions, I can make this vector representing with current I, because there is an angle 0 with respect to x-axis here. Now suppose another example, 5, or we can say 6 sine omega t plus 30 degree. This current I2 can also be represented in the form of vector. So here it makes an angle 30. And this is the vector called I2. This is I1. Now what are the divisions? 6 divisions, 3, 4, 5 and 6. So this is your current I2. So we can represent current I2 in this fashion also. And what is the equation here? Equation is 6 sine omega t plus 30 degree. Similarly, if the another current which is acting in the same plane called I3, say for an example, 4 sine omega t minus 45 degree, here. So this minus shows that it is a lagging quantity, plus shows that it is a leading quantity. So with reference to this x-axis, I2 is a leading quantity, I1 is coincide with the x-axis. What about I3? I3 is lagging quantity. Okay, this lagging quantity you may find it out by subtracting from 360, and you can draw the vector in this fashion. So 360 minus 45 is 315 here, and this angle, that is 315, and that is a vector called I3. In other way also you can represent, that is minus 45 degree. Okay, but always we will consider in anti-clockwise directions from 0 or from x-axis, and we can write these expressions. So here I3 is 45 degree, and what are the divisions? 1, 2, 3 and 4. So there are 4 divisions, and we can represent this vector I3 also. Now what is the significance of representing all these quantities in a single waveform, or we can say single graph paper? Suppose if we want to add these 3 different currents, I1 plus I2 plus I3, then what we have to do is we have to make a simple total equivalent current by simply inserting the values of I1, I2 and I3. Omega t plus 0 plus 6 sine omega t plus 30 plus 4 sine omega t minus 45 degree. Clear? And if you solve, you can find the amount of current flowing through this. So here we need to solve sine alpha plus beta, sine alpha minus beta, and we should know the conversion of this sine alpha plus beta and sine alpha minus beta. Okay, but there is another method which we are going to follow today, and we are going to solve some addition and subtraction. Similarly, we can have vector multiplication and division also. Clear? So all the different quantities that we can represent with an angle, and if the equations are given, we can draw that vectors and we can find the resultant vectors also. Now we can resolve all these vectors I1, I2 and I3 either on x-axis and either on y-axis. And with the help of law of parallelogram, we can find out the resultant, and this resultant can be the addition of these three different vectors I1, I2 and I3, and we can find. So here we are going to find out the x component as well as y component, and finally after adding all these two we can find the resultant of this x and y component with the help of law of parallelogram. So we can find the resultant of it, and accordingly we can get that addition of all these three currents, or it may be a voltage also. So instead of I1, I2 and I3, it may be a V1, V2 or V3 or E1, E2, or E3. Fine. So let's have one example. Based on this, we are going to solve one example of this vector representation. Fine. So here I'm going to give you one example. So there are two different currents, and first of all we are going to draw the vector diagram, and after that vector diagram we are going to have the addition of these two different vectors with the help of law of parallelogram. So here current I1 is represented as 4 sine omega t minus pi by 4. Pi by 4 is 45 degree, and I2 is equal to 2 sine omega t plus pi by 6. So pi by 6 is 30 degree. 180 by 6, 30 degree. The question is to draw the vector diagram and find the resultant current. Find the resultant current of the given equations. Now here the first step is to draw the vector diagram. Here the magnitudes are given 4 and 2. Fine. So first of all we will start with current I1. I1 will start from here. The angle is 45 degree here. Pi by 4 is 45 degree. With respect to x, we will draw 45 degree, and the magnitude is 1, 2, 3 and 4. We can represent current I1 like this with an angle pi by 4. Pi by 4. Am I right?
No, sir, it's lagging. It's
नीचे नहीं आएगा
Correct.
माइनस पाई बाय
On, yeah, it will be on the below x-axis.
क्वाड्रेंट में आएगा ना.
I hope all of you understood now, because here it is a minus sign. Fine. So this is the wrong I1. The correct I1 is at the bottom side, minus 45 degree. Are you with me, all of you?
Yes sir, बस I have doubt.
Yes, sir.
सर
Yes.
सर के फोर्थ क्वाड्रेंट में लिखते हैं पाई बाय 4, तो उसमें माइनस की साइन लगा ना क्यों, मतलब वो तो पता चल जाएगा कि वो पीछे है.
See, every time we will start it from 0 in anti-clockwise direction. Fine. So this is anti-clockwise direction, am I right? And if there is a minus sign, then we will subtract it from 360. Fine. And then we will find out the correct angle, that is 315 degree in an anti-clockwise direction. So this angle is 315. Either if you write cos 315 and if you write cos minus 45, you'll get the same answer here in both the cases. Clear? So this way you have to understood, but sorry, I just remove everything. I1 is, I just repeat 4 sine omega t minus pi by 4, and the second one is I2 is 2 sine omega t plus pi by 6. Okay. Do you understand what exactly I mean to say? Suppose if the third, yeah, if the third one is there, I1 or I3 is equal to, say for an example, 6 sine omega t. Now in this case, what will you do? We know that I3 current is having no angle phase difference between the quantities. Fine, it is coincide with the x-axis. So this is x-axis and divisions are 6. 1, 2, 3, 4, 5 and 6. Okay, I can represent current I3 here, I3. This is I3, or we can say it is I3. Okay, now I can represent all the different quantities in anti-clockwise fashion only. Okay, because as and when we found the alternating current with the help of Faraday's law of electromagnetic induction, in which the coil is rotating in anti-clockwise direction with respect to omega radian per second, with a speed of omega radian per second, right? And we always consider in either one direction only. So if you want to solve this example, either you find it out in anti-clockwise or clockwise, but always we will consider anti-clockwise for all this different vectors representation. Okay, so right now you will not consider this one. We will consider only I1 and I2. Okay. In this case, we can write and we can draw that vectors also. So here it is minus pi by 4. Either if you have a number, right, you can directly draw this vector by 45 degree. It is in the negative side or fourth quadrant. Otherwise, what you have to do is you have to convert it from 360 minus 45 degree, and you will get 315. Either you draw it in anti-clockwise direction this way, fine, with an angle of 315, or either you can draw in a negative side with minus 45 degree. Clear? Now this is plus. So we know that with respect to the x, the another quantity which is leading quantity here, and this is an angle 30 degree because it is pi by 6, so 30 degree. And how many I mean, what is the magnitude here? Magnitude is 2 here only, so we can draw the magnitude as 2. This is 2 compared to this 4, it is 2, and we can represent this is current I2 and this is current I1. Okay, now according to the law of parallelogram, first of all we are going to write x component and y component. X component means we have to resolve this current, on x-axis, and on y component, which is perpendicular, or we can say 90 degree at x, we can convert all these components, or we can resolve these components on y also. Fine. So let me write x component first of all. Why we are doing this? Because we are finding the x component. So this is x component, this is y component, and with the help of this x and y component, we are going to find the resultant one. Fine. Okay, so how to write an x component? We can write an x component is equal to, what we are going to do, first of all we are going to start with I1, I2 and I3 And then we are going to write the cost term, because if we resolve this I2, if we resolve this I2 here, and if we resolve this current I1 to the x-axis, so we can write 4 cos 315 degree plus I2 current. I2 current is magnitude is 2 cos 30 degree. Okay, so this is positive 30 positive, 300 positive. We can write this x component. Similarly, we can write y component also. And y component is 4 sine 315 degree plus 2 sine 315 degree. After finding this value of x component, because it is an current, so it is represented with an ampere, we can find the resultant is under root of x component square plus y component square. How it is? Because if you find this is x component, if you find this is y component, fine, y component, with the help of law of parallelogram, we can find this is the resultant one, current I resultant. Okay, so this is x component of current I, this is y component of current I. Okay, and this current you can find with the help of this equation, resultant is equal to under root of x component square plus y component square, isn't it? And after finding this, you can find the magnitude in ampere of resultant. So this is the magnitude that we do not know whether it is going to act in this way also, whether it is going to act this way also, whether it is going to act this way also. Fine. We need to find it out. We need to find it out. And if we find it out, then we can have this vector representations. And after this resultant, we can also find the angle at which it is going to be acted. Fine. And to find it out an angle here, so this is y component, the similar component will be here, and we can find this angle phi. So tan phi is equal to y component, because this is the y component, this is y component upon x component. So with the help of this equation, we can find even angle at which the quantity is going to be acted upon, y component upon x component. For calculation of this x component, y component, resultant, and theta, you should know how to operate the calculator, isn't it? You can find tan inverse with some value, and you can find the angle in degree, and you should know how to convert all these different parameters from degree to radian, radian to degree, and all these things. Cos at 315, all these different parts. I hope you understand this one. And finally, if you find the resultant, fine, then you can find the current I is equal to I1 plus I2 is equal to, you can write resultant. So whatever the amount of current that you will find it through resultant, then you can write sine omega t. If the angle is positive, if this phi is positive, then it will be a plus sign plus an angle which you need to write here, phi. And if this angle is minus, then you have to write minus sign here, and you can write the resultant of this current I. This you can directly add these two different equations, and you can find I1 and I2. You can directly subtract even I1 and I2. Example, LNC series circuits. Now let's say one more example. Okay. Three voltages are represented by V1 is equal to 100 sin omega t, 100 sin omega t. Okay, I would like to change the value here. Instead of sin, it would be cos 250 cos omega t. V2 is equal to 150 sin omega t plus pi by 6, and third quantity V3, that is 200 sin omega t minus pi by 4. Find out the resultant voltage. Find the resultant voltage of about three vectors V1, V2, and V3. Okay. First of all, what you have to do is you have to match all these three equations with your equation of V1 or V. V is equal to Vm sine omega t plus or minus phi. Okay, so this sine term should be there, but in this case here the term is cos, here it is sine, here it is sine. For V1 you need to convert into sine, but V2 and V3 are already given with sine, so you can use it directly into the vector form. V1 is 250, so 250 is your maximum voltage, Vm magnitude. Now cos omega t plus or minus 0, that we can write because there is no angle here, phase difference. Okay. Now if I want to convert this cos into sine, I may write sine. Can anybody help me? Can anybody help me?
90 minus theta.
Can we write like this?
Yes, sir. Yes, sir.
Correct?
Yes, sir.
Yes, sir.
Okay. So we can replace this expression here. Okay. In examination, such kind of alternatives way they give any kind of question. Fine. So here 250 sine omega t plus pi by 2, isn't it? And we can draw the vectors here and we can complete the example also. Okay. First of all, let me start with V1. The vector magnitude is 250 and the angle is pi by 2, 90 degree, and there is a pi by 2, 1, 2 and half. So probably here we can say it is V1 and this is your vector V1. Agreed? Similarly, vector V2 is plus pi by 6. Pi by 6 is 30 degree. We can draw. This is V2 with an angle 30 degree. And similarly, this you may represent with omega t plus 315 degree, or you can represent it in minus 45 degree. Okay, so this is your 315 degree, and another vector that is 200 called v3 vector, fine, or you can represent it with minus 45 degree. Sometimes it may be possible to get confused, because if the vector which is pertaining to the quadrant 3, so you have to either use the anticlockwise direction consideration or this consideration. Clear? So please keep in mind, if you follow all these plus values, I mean anticlockwise direction from x-axis, then you add all these positive numbers, either subtract it from 360 or find it out the values. Okay. Now we are going to find the x component here and then y component. X component is equal to, first of all, we will write in the term of v1. V1. Okay. We are just resolving all these components onto x-axis, x-axis, and x-axis. Okay. This will be an angle 90 degree. So we can write v1 cos 90 degree. And what is the value of v1 here? v1 is 250. We can write 250 cos 90 degree plus v2. v2 is how much? It is 150 cos an angle 30 degree plus the third one is 200 cos 315 degree. Even you can write it here also, cos minus 45 degree. The value will be same here of these two different values. And if you find the value here, that will be your vector v, which is represented with the voltage because it is the vector quantities. Okay. Find out and tell me what is the value of this 250 into cos 90. First of all, find out cos 90 multiplied by 250. Then add these three different terms and find out the final value of this. Y component is equal to 250. You can easily write the y component, fine, by simply replacing cos term in the above equation, plus 150 okay. Find out the x component and y component as early as possible. I hope all of you have calculator and can calculate easily of x component and y component. For time being, please calculate it by your own. For time being, I may consider it is 400 volt and it may be 300 volt. Fine. Please find out the exact value here. I simply just write the numbers here only. Fine. Now we can represent this x component and y component, and finally we can find the resultant of it. Okay. So this is your x component. After resolving all these components, you will find this x component, and after resolving this, you will find y component here. Okay. And simply you can find resultant is equal to under root of x component square plus y component square. And this is your resultant one. in different examples, it may ask that please draw the resultant also. So whatever the magnitude you received here, according to that you need to draw. This is your resultant current I, which is addition of all these three. Okay, and you can also find an angle phi, that is tan inverse y component on x component. And whatever the angle you find, say for an example, if you get 30-degree, fine, then you have to mention that this is at 30 degrees. Suppose if you find the minus 30-degree, then this resultant would be at minus 30-degree. Or we can say 360 minus 30, 330-degree. And you can represent this is 330-degree. You can also mention in the same diagram, I mean, this is your V1, and this is somewhere here it is V2, and somewhere here it is V3. And you can represent this vector, that is, if it is minus, you can represent here. If it is plus, you can represent it here. Isn't it? So this is the vector representation, and you can add, subtract, and even multiply also, and you can divide also all these different vectors. So any vectors acting in a similar plane, we can write the different equations, isn't it? Okay. Now our next theory is AC through purely resistive circuit and AC through purely capacitive circuit and inductive circuit. Okay. Now we will see the behavior of different circuits when it is connected as a resistor load, as a capacitor load, and as an inductor load. Okay. Now we are going to write an expression of voltage of this source, because this source is AC source, alternating voltage. So always we are going to write an equation of V is equal to Vm sin omega t. If we apply the voltage across any passive elements, here passive element is a resistor, it may be capacitor, or it may be inductor, and their combinations of the circuit. So we are going to find out the behavior of the circuit while connecting all these passive elements individually or in combination of series and parallel. Okay. So let us have an example of resistor here. We know that the source voltage equation is V is equal to Vm sin omega t. And with the help of this, and with the help of the behavior of the passive element, we are going to find out the equation of current I in all these three different cases. And accordingly, we can find the equation of voltage which is applied to a series or parallel circuit, and we can find the equation of current, and finally the equation of power. Okay. Now we know that if the resistor is connected, and we can directly apply the Ohm's law, that is V is equal to IR. And we can find the equation of current here. Okay. So let us first of all consider AC through purely resistive circuit. So here there is only a resistive circuit, nothing else. Okay. We can write according to the equation I is equal to V by, and we know that the equation of V is equal to Vm sin omega t. This is equation 1, this is equation 2. And from this equation of voltage, we are trying to derive an equation of current. So simply we can replace the value of voltage here, and we can write the equation of current I is equal to Vm upon R sin omega t. Sin omega t. Okay. Now if I want to draw the waveform of voltage, because it is a reference quantity, we can draw the vector with respect to time t here, plus or minus 0. It means it starts from 0 at t is equal to 0 here, and it will acting upon like this. So we can write this is V is equal to Vm sine omega t. Okay, because there is no phase difference here. It starts from zero only. And this is, we can consider it as a reference quantity, voltage. And here we are finding the equation of current also from this equation. Okay. Now, the value of current I will be maximum. In this equation, maximum current कब मिलेगा हमें? At what degree? Here we can write this is current I and this is the maximum value. Fine. This is the maximum value. So if we want to find out the maximum value here of current, maximum value of current, the angle of sine would be 90 degree. So at
90 degrees.
yeah, you will get the maximum value. Fine. So if I keep the value of sine omega t is equal to 1, or we can say is equal to 1, we can get the maximum value also. Okay. So in that case, we can write Im is equal to Vm upon R. Sine omega t is equal to 1. 1 कब आएगा? At what time? In this case, when will you get sine omega t is equal to 1?
90 degree.
Sine 90
Theta
is
is
what?
equal to 90 degree.
Yeah, sine 90 is equal to 1 and sine 0 is 0. Okay, so when we get this 90 degree, we'll get the maximum value of the current. And if sine omega t, sine 90 is 1, then we can write the maximum value of current, that is Vm upon R. Clear? So we can write the expression of maximum current is equal to Vm upon R. This is an expression number 3 here. And with the help of expression number 1, 2, and 3, we can write I is equal to Im, because here we can replace this Vm upon R with Im sine omega t. Sine omega t. So when the resistor is connected, we can derive an expression of current from voltage, and we found this equation Im sine omega t plus or minus 0. The meaning is what? The meaning is that there is no phase difference here also. There is no phase difference here also in a voltage equation and current equation. That means their shooting of time of current, maybe from 0, it will reach to the maximum value at the same time. Again at 0 at the same time. In negative half cycle, the maximum value here at the maximum in the negative side and will be here. The meaning is what here? There is no phase difference between voltage and current when the resistor is connected as a element. I is equal to Im sine omega t. It means the voltage and current both are in phase with each other. There is no phase difference. And for that reason only, here you can see, here on the top of the circuit, they shown that VR and I, the vectors are in the same direction. And the angle between these two is 0 with respect to x-axis and y-axis. Fine. I already explained to you what is phase and phase difference. So in purely resistive circuit, we have two different equations of source voltage Vm sin omega t, and from which if we derive, we can also find Im sin omega t only. There is no phase difference. It means there may be a possibility of change in magnitude of voltage and current, but their shooting of time reaching to the maximum again reaches to the 0 value and in negative direction at the same time. Fine. So here the time period is same, capital T, time period is same in this case. Okay. Now after discussing all these three different circuits individually, then we will go for power and power factor, and we will discuss about power and power factor also. So this is purely resistive circuit. Similarly, instead of resistor, if inductor is connected, inductor is connected, then let us see the behavior of the circuit, and then we will continue with capacitor also. Okay, we have only 4 minutes, so let me finish part, and then we will continue with RL series circuit. Okay, now purely inductive circuit. Yes, anything else? Question? Any question is talking to? Any question? Now, purely inductive circuit, where the source voltage is your V is equal to Vm sin omega t, and inductor is connected. Where there is an inductance, the amount of current is flowing. So only inductor is connected, and we can find the equation of current I here. Okay. Now, the applied voltage and induced EMF, self-induced EMF are always in opposite direction, So the applied voltage is V here, induced EMF is E, say for an example here. We can write V is equal to minus E. V is equal to minus E, where V is the supplied voltage, and we can draw that vector of supply voltage in this fashion. Clear? Now, this is V is equal to Vm sin omega t. As the voltage, there is no phase difference. It's fine. So we can start at t is equal to 0. Okay. Now, according to the law of inductor, we know that the applied voltage and the EMF is induced. Self-induced EMF is always in opposite direction. So we can write this. Okay. So minus E. Now, we have also derived in inductive circuit the equation of E, that is minus L di by dt. With respect to change of current and inductance, there was an equation we have derived. Okay, so here we can write V is equal to L di by dt. Our equation V is equal to Vm sin omega t is also there. So from these two different equations, both the equations are of voltage, and we can write by equating these two equations like L di by dt is equal to Vm sin omega t. Isn't it? Now, integrating both the sides, we can find the equation of current. So our intention is to find out the current equation from voltage equation. So voltage equation is true. Okay. Now here we can rearrange these terms, and then we can find by integrating these different equations, we can find the equation of current also. So di by dt, so di is equal to Vm upon L into sin omega t into dt. Yes or no? So simply we replace this value here and here to here. So we can write di is equal to Vm upon L sin omega t into dt. Now integrating these equations, both the sides, we can find the current flowing through it. Okay. So what is the equation now? The equation becomes I is equal to Vm upon L sin omega t, and the integration of sin omega t is minus cos omega t. Minus cos omega t upon omega. So we can write Vm upon omega L into cos omega t, or we can say it is a minus sign here. Okay. And finally, we can write an expression of current. I is equal to minus Vm upon omega L cos omega t. Now, if I want to represent this cos term into a sine, we can write Vm upon omega L, where omega is 2 pi f. Omega is 2 pi f into L. Then we can write this cos term into sine, fine, omega t minus pi by 2. We know that cos pi by 2 minus omega t is equal to cos omega t, but this minus sign that we have shifted to inside. So we can write sine omega t minus pi by 2. Okay. Now, after this, we can write the final equation of current I in the form of this sine omega t minus pi by 2. Minus pi by 2. Okay. Okay. Now, for getting the maximum value, this term should be unity 1. So when it will be possible, when sine 90, then it is possible, it is unity. Fine. So in that case, we can write I is equal to Vm upon omega L. Omega is 2 pi f. So you can write 2 pi f also, 2 pi fl. And then this would be 1. जब ये 1 मिलेगा आपको, तब आपको मैक्सिमम वैल्यू मिलेगा, एंड यू कैन राइट दिस इज आई एम मैक्सिमम वैल्यू. फाइन. सो ओमेगा टी माइनस पाई बाई 2 आपको ऐसे वैल्यू डालो जैसे आपको ये साइन वाला टर्म 1 मिले. ओके. मतलब 1 या 1 से कम होगा. अगर 1 है तो मैक्सिमम वैल्यू मिलेगा, 1 से कम है तो उससे थोड़ा कम कम वैल्यू मिलता जाएगा. Isn't it? So here you can write Vm upon omega into L. Okay. And if you replace the value of this maximum value equation of current I, you can find current I is equal to Im, because we are replacing this term with maximum value Im into sine omega t minus pi by 2. Minus pi by 2. So this is an expression of current, and the equation of voltage is Vm sine omega t. So here we know that the equation of current
Thank you, sir.
Yeah. Still, just a minute. I would like to finish that part only. Okay. So we can draw that diagram here of current, because there is a 90-degree phase difference, minus 90 degrees, so lagging quantity. And we can represent the value of current in inductive circuit like this only. I is equal to Im sine omega t minus pi by 2. Minus pi by 2. Okay. So this is your difference of voltage and current when there is a purely inductive circuit. That means the voltage is always leading quantity by 90-degree, and current is always 90-degree lag. So in this figure, that is represented that the voltage quantity is a leading quantity, and current is a lagging quantity by 90-degree here, when it is a purely inductive circuit. Fine. In the next lecture, we will continue with the purely capacitive circuit, and then we will have a combination of all these RL, RC, and RLC circuits, and then we will derive the different equations. And finally, we will go for power factor, and the relationships. Fine. Okay. Thank you. Any more questions? If you have, you may ask. Otherwise, we may stop here.
Thank you, sir.
Yeah. Fine. Thank you.
Thank you, sir.
Welcome. You may leave now.